Okay, so we'll go ahead and get started. Let's see here. Yesterday, which side of the room do we start on? I think it was that side. Okay, we'll start over here. Okay. So I think we'll just start on this side, and we're just going to snake our way in the back row, then towards the middle row, then the front row. Okay? So,
I think you should ask the questions.
that's, and we'll branch off that. So, name a hormone. Starting here. Aldosterone, okay? Excuse me. And these can be at random, okay? So we have aldosterone, okay? Then we go next. So we're just moving left to right in the back row. Okay?
Wait, what is like gonadotropin? Is that like
Gonadotropin just means it's a hormone that has an effect on gonads, whether it's males or females.
So gonadotropin is a hormone.
Gonadotropins is a classification
Of
of the,
class
yes,
of hormones, like a group of hormones.
yes.
Gotcha.
Okay? Next.
Cortisol.
Okay? Next. 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 I see a pattern arising here. Okay? Now, why would we say that? With what we've done so far, what pattern do we see other than it's a blue marker? Yeah, those are all steroids. Okay? Next. 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 I shouldn't keep doing that. Okay? So if we really wanted to abbreviate that, we don't have to write parathyroid hormone. We can do what? Okay? Okay? You know, I was wondering if someone was going to come up with that, and we're going to stick with this for now, which is a good point. I'm glad you brought that up. Okay. Oh, I don't know why I'm doing that. Yes. I think that's an O, actually. I don't think it's an E. Oh, that is right. Except for, yeah, that looks like a U, but it's actually an O. It's just bad handwriting. Next. Say that again. Okay. Probably not that it needs to be capitalized, but it makes more sense to me if it is. So I think that is, oh, there's always room for one more. Mind like a steel trap. So then, look at what we've been doing. Guess what we want you to do? That is one, but I want you to be a little more specific with it, though. When you said GH, that is a hormone, but I want you to be more specific than that, though. Okay? All right. So then, now, to me, what I think we could possibly do is then start saying, well, are these steroids? Are these non-steroids? Are these, which we see that pattern already arising from this because we'd mentioned that earlier. What do these all have in common? Yeah, so these are all steroids, okay? So we'll just go ahead and do that, okay? So then we'll just put a big S in there. Just what makes sense to me. So with what we have left, what I want you to think about, when you know what something isn't, you can figure out what something is. The reason I say that is with our remaining sets of classifications, we said there are 4 types, so we've already eliminated one, your steroid hormones. So what does that leave left for classifications? Now, not because if it's a gonadotropin, not if it's a mineralocorticoid. Sorry, I didn't mean to interrupt. Structure-wise then. That's too vague. Need more specific.
Like what they're composed of?
Well, yeah, it's composition.
Like amino acids,
Okay, that's one.
amines, and polypeptides.
So then we'll just write amine up here. Now, even though we say that we have these amine-based hormones, which we do, but the difference is we still classify them as amino acids. And here's why. Because when you look at 2 of them, we had done this earlier. Okay? Actually, that might be turned 90 degrees. I'm not quite, okay. This, and then we've got these branching off of here, which I can't quite remember the structure for sure, but that is accurate so far. And this would possibly make a good matching question. And you might think, oh my gosh, I'm not going to be able to remember the difference between these 2. Okay? But just like hopefully we could agree with a lot of other structures we've gone through, we can give you a clue. Okay, so we've got this, OH, we have this, and then I believe it's NH2. Okay. And we'll draw this very similarly. I think that's an OH group. Yes. OH group up here. And then I think that's correct. Yes. Then what am I doing? I got the right idea, but I'm just putting them in the wrong spots. This needs to come down here. That's what's throwing me off. Okay. Okay. So this is the two chemical structures for what we would consider being norepinephrine and epinephrine. You might think, well, how am I ever going to remember the difference between these two? Okay? Because they are almost structurally identical. Okay? But the difference between these, okay, this is norepinephrine and this is epinephrine. Okay? And if we remember from our physical science days, and no, we don't have any seniors that were in general chemistry last year, but from physical science, if we had this type of a structure, what is that called? CH3 from your physical science days. It's called a derivative.
Glucagon or glucose, something like that.
No.
CH3.
3-carbon compound is called propane, but in this case, we have a methyl group branching off of that. So what does that have to do with this? Okay. Notice we said these are structurally identical except for right here. Okay. What I want you to think about is how many carbons are branching off of norepinephrine.
A lot.
How many is, because I circled the functional family here because that's what we're doing. This is what categorizes these as an amine-based hormone because NH2s are characterized as giving you amines, okay? But the top, norepinephrine, has how many carbons branching off of how many carbons are branching off of here?
One.
Well,
Maybe two.
there's two. This one's got, okay? So one of the ways to keep them separate is since this is epinephrine with an E, this one has an extra carbon. So maybe think of it that way. When you're looking, I don't expect you to be able to draw these. That's way too common. It's not that you couldn't, but why would we force you to do that? I can't come up with an answer for that, but what I can come up with is if you saw this as, for instance, as a matching question, how do you know you're looking at epinephrine or if you're looking at norepinephrine? This would be the key. This has that extra carbon on it. Hopefully that makes sense. Okay? Now, what about, see, our organic chemist wasn't in here. Shoot, and then I erase it. I don't know what I did that for. I had this. What is that called inside the box? It's a derivative. Yeah, it's an extra methyl group. So what we're talking about here is this has that extra methyl group, okay? Even though it's branching to a nitrogen atom, we would just consider, say, okay, it's got that extra carbon, it's got that extra methyl group, so then let's categorize this as epinephrine because of that as opposed to norepinephrine. All right. So now, which one of these two is going to raise your heart rate? Okay, so the heart rate will raise. Okay, which one of these would we categorize as preparing you for what we learned last chapter as the flight or fight response? Epinephrine. Okay, so we could say the flight or fight response. This is lacking that. This is going, because the heart rate is going up, the cardiac output is going up. Where is this increasing the amount of blood.
To the brain.
Right idea. Wrong one.
Wait, norepinephrine?
We're talking about this one down here.
Epinephrine.
Okay,
To the
so
body.
this one also increases the cardiac output, but this is increasing blood through the entire body because it's part of the flight or fight response. This one, however, how you had mentioned, will increase blood to the brain. Okay? So I suppose we could just do this, increases blood to the brain. That's what we're talking about here. Because no one could really argue with that. If we're talking about heart rate, cardiac output, we're talking about the amount of blood that's being sent either through the body or to the brain. And when this happens, the rest of the body is preparing you for the flight or fight response. Okay. We can leave that up there. So now we know that, okay, we're just going to put AM for amine. Okay? So to me, what makes the most sense is now we want to focus on these here, our polypeptide-based hormones. Because remember what we said, once we, I don't know if you say figure out or categorize what something isn't, you can certainly figure out what it is. That's why we put a box around here. We know that these can't be polypeptides. We know that these can't be amino acids because these are steroid-based hormones. We know that this is an amine-based hormone. So now we want to focus in on these polypeptides. Okay? So with that, okay, which one could you say for certain is a polypeptide-based hormone? And I'm going to tell you that two of them are in your lower left-hand corner. And lower left-hand corner here, too. ADH is a polypeptide-based hormone. Okay? So what is right next to ADH? Oxytocin. So we know that is a polypeptide-based hormone. Okay? And when we think of this, really, I think there's only 5 polypeptide-based hormones. Okay? So then, I'm sorry, and I had cuts, not that I cut them off. Someone said insulin, because, did someone say insulin?
Yeah.
Okay. So then notice we've got insulin and then glucagon. Okay? So that must, oops, that's a P. And then I believe there is one more out there. Close. I don't know if it's that either. Yes, it is. See, I get these two, because I get it in my mind. We've got this one and then TSH. For some reason, I get them two confused. That is correct. That is not correct. Okay, so you say thyroid stimulating hormone, that is a polypeptide-based hormone. So what that means then is we've eliminated what everything can't be. These can't be what's left over, amino acids. These can't be amino acid-based hormones because we've categorized them. That must mean once we have this, we just look at what's left. And that is, this must be an amino acid. This must be an amino acid. And then this one must be an amino acid. And I got to come back to the comment that yourself had made, which was a good one, is you're maybe being too specific over there. You said thyroxine and T3, which brings up a point. What is everything you can tell me about thyroxine in the T3 form? Which is a good point. I'm glad you brought that up.
It is 3 iodine.
It would have 3 iodines on it. That's true. well, it's got to be, if you're saying it's more potent, which it is, you have to make a comparison to that.
More potent
Than T4. That's right. Okay. So then, again, I just wanted to throw this up here that you probably know more than what you're actually giving yourselves credit for. Okay? So then, last thing we could do, we had a latecomer to the show here. I don't know. This should be for everyone's entertainment. This is a show, right? Nah, I don't know. Name a hormone. Because notice, everyone went through here named a hormone.
Any hormone?
Yep.
Even if it's on there?
But not if it's on here. So what you could do is look at those that counteract one another. Or are related to one another. There's a whole, I wouldn't say a whole bunch of them. There's probably about 3 left. That might make it a little more difficult.
FSH. Follicle stimulating hormone.
Okay, and even though this is not on the list, it still is one, okay? And as far as categorizing that, I really couldn't help you with that. So when we say follicle stimulating hormone, what do you suppose that's having an effect on? Is it men only, women only, or both? That's what makes this a tough question.
What was your question?
We say follicle stimulating hormone, okay, it's going to be tied to reproduction probably,
Women.
but can it be tied to men? Okay, this is more so associated with that. To women, that's correct. Follicle stimulating hormone, that's probably going to have an effect on female ovaries, would be one, okay? And then perhaps the uterus would be another one, because those are what we consider the follicles of the female human anatomy. So it's a physiological function. So we really don't categorize this having an effect on men because it's what a physiological function that we mentioned before. Women have to go through this. We said before, guys, we lucked out on this. So just the way the man upstairs designed us. All right. So that's really all I have that I wanted to go through, unless, which one of these could we say go in pairs? Maybe we should do that. Okay, so these two. And you're right, but why is that significant? They go in pairs because what type of mechanism do they make? Negative feedback mechanism, because once one's stimulated, the other one's going to try to counteract that. Okay? Is there another set of hormones up here that work in pairs? Okay, we could say that those do. Yes, these do work in pairs, and I'm glad. Do we say that they work in a negative feedback mechanism? No. Positive feedback mechanism, because look at what is happening here. We're amplifying a change that's occurring. Is there another one that we could throw in with this that is also a positive feedback mechanism? Oxytocin, this one right here. Down here, not up here. Okay, so what is significant about this hormone called oxytocin? Why is it a positive feedback mechanism? It's going to cause contractions in female mammals and female humans. Okay, there's still another one up here that works in pairs. That's one and that's two. Now, for our purposes, one of the things that we say is these are specifically what type of hormone along with this one here. We'll put all 3 of those together. I mean, what do we categorize them as? Yes, I understand steroid non-steroid, amino acid, cholesterol. The function is what we mean. Right. But I think, like I said, for our purposes, we want to know these as mineralocorticoids because they deal with calcium. I believe if you really want to talk about minerals, it's only sodium ions, which then you would eliminate these two, which must mean this is the only mineralocorticoid. But we don't want to look at it that way. We want to establish this as, we know that this is sodium and this is associated with then, of course, with calcium. All right, I think that's enough. There's a little bit of time left, so I want you to have that time to look at this and say, I don't know what we're talking about here. So notice we've been spending a lot of time on hormones and their functions. Okay, that's a big part of understanding what endocrinology is. And this isn't all of it either. There's more to it than that. Okay, we'll catch up to you next time.